My name is Hening, and I'm glad to present our joint work with Leixin and Ondřej about our work here. I will first give you a brief outline. I will first introduce our phenomena, and then I will uh, introduce our data set, and then I will present our analysis, results of our analysis. And finally, I will conclude with an outlook. So the phenomena we're looking at is the use of multimodal information during translation. Humans uses various stimuli beyond just text information, while machines typically rely solely on textual input. So to tackle this problem, we thought we could approach this with a comparison from both sides. And by previous experience that we have in cognitive science, we can get meaningful understanding of both systems in doing so. So the goal of this present work is then by examining how humans process sentences in real-time translation, we want to identify strategies to improve the state-of-art machine translation algorithms, making them more adaptable and contextually aware. That brings us to our research questions. Our first research question is, do machines and humans exhibit comparable difficulties in processing ambiguous versus unambiguous sentences? And our hypothesis for that question is, higher processing complexity should be shown for both humans and machines. Our second research question is, do visual cues impact human translation outcomes, and which of them in human translation could align better with machines' outcomes that rely solely on textual information? And our hypothesis for that would be visual conditions affect both human translation and of machine. Processing should be more similar to human translation results when no additional visual information are provided. So one important aspect of our current analysis is our data set. The data set is called EMMT, eye-tracked multimodal translation. This is an open source data set which you could find online. This is a rather like a psycholinguistics experiment than the AI experiment with machines. This experiment comprised of 43 human participants. The images and texts comes from these three big prominent data set that is standard for benchmarking tasks. But in our experiment setting, the tasks for participants are translation from English texts to Czech texts. And the methods we are using here is a combined methods with eye tracking and EEG. Below, you will find a brief scheme of our experiment trials. The experiment trials have four sub steps. The participants are expected to read a text first and then provide their first translate of that text. And then, according to the condition they have received, they have the opportunity to see one more picture. This picture I will come to that later. And after they seeing this picture or not, they have the opportunity to update their translate and provide a second translate of that source text. So more to the visual cues and ambiguity, we have these two aspects as our two factors. And for the ambiguity factor, we have two levels, unambiguous sentences or ambiguous sentences. And the second factor, visual cues, has three levels, no images at all, an unrelated image or unrelated image. This result in 2 by 3 cross design. And below you will find a sample screen of the experiment. And these dots are the eye gazed dot from the eye tracking. And while eye tracking, the participants are having a EEG. So let's jump right into our results. First, we want to see how the visual cues impacts the update quality of the translation. We use normalized similarity ratio as our matrix. And for statistics, we use linear mixed effect modeling and model comparison with ANOVA. So we have found a significant influence of visual cues, and this is due to the comparison between no image versus unrelated and related images. If you can see my cursor, you can see that there is almost merely no differences between unrelated and no image condition, but there is um, a huge difference between related images. And then we want to measure the similarity of translation outcomes between participants. And for that, we use the matrix of blurred. This is a similarity ratio comes from a BERT transformer architecture. And results are shown that there is a significant differences between related condition. That suggests that there is more similarities of updating and outcome in that condition. That would be indicated that a related image could reducing the information vagueness. And also we find, although the statistics are not significant, but we hypothesize that unrelated images might serve as distractions for subjects. So finally, we want to compare human translation with machine translation. We evaluated 4 machine translation systems: Google, Lindet, DeepL, and ChatGPT, and the metrics and statistics are same as last slide with blurred. And here we found that no images provided best human-machine alignment. And Lindet is among that 4 systems showing the best human-machine similarities. So to conclude, we found when related images are provided, there is a tendency for more words updates in translation correction phase. And in the context of comparison across subjects, we observe that translate will be more similar when they are exposed to related images. And for future work, we want to having the machine translation system let them to have access to the image, then we could have a more close setup to our psycholinguistic experiment settings with human participants. So that's all. Thank you very much for your attention.